Welcome to the specialization on mechanization in construction. This specialization includes 3 courses: construction machinery for concreting, roads and earth moving, TBMs or tunnel boring machines, pile rigs, cranes and hauling vehicles, and construction equipment maintenance and safety, providing valuable insights into mechanization in construction. I am Kasi Raja V, serving as Vice President and Head of Plant and Machinery and Special Projects and Construction Methods Department at L&T. I am the lead subject matter expert for this course and have developed it in collaboration with my team of experts. Construction projects are growing in size, leading to the use of increasingly larger and more advanced equipment. At the same time, project timelines are getting shorter, with the clients expecting bigger results in less time. This is where mechanization in construction plays a crucial role, incorporating a diverse range of equipment from batching plants to tunneling machines monitored by digital tools. Mechanization has greatly enhanced the efficiency, safety, and quality of construction projects. The addition of digital technologies further amplifies these advantages, ensuring that modern construction practices can meet the demanding needs of today's infrastructure and building projects. Safety protocols and the use of smaller tools also support this advancement, creating a comprehensive approach to the contemporary construction. To manage these large-scale projects effectively, key innovative methods and cutting-edge equipment are essential. Our focus is on mechanization. What is mechanization? Doing the construction activities by utilizing machinery to perform the tasks that were once done manually is called mechanization. This transition not only accelerates the construction process, but also improves the accuracy. It also improves quality and safety standards and lowers the dependency on the labor. Needless to mention that today we are finding it very difficult to get skilled workmen. We begin by exploring the evolution of mechanization by introducing mechanized equipment for various tasks in the construction industry, right from the earth moving and material handling to the lifting and finishing. These equipment are crucial for site preparation, excavation, foundation, and landscape shaping. Most of the latest mechanized equipment comes with hydraulic systems, which eases the operation. These machines provide the power and control needed to handle heavy loads with less human efforts and perform tasks with precision. This course also highlights concreting and road construction equipment, which includes machineries like concrete mixers, batching plants, transit mixers, concrete boom placers, pumps, hot mix plants, asphalt plant, compactors, etc. Our course explores into tunnel boring machines, TBMs. This is an advanced equipment used to excavate tunnels through various ground conditions such as rocks, soil, and mixed terrain. TBMs are crucial for constructing tunnels for transportation, utilities, and other infrastructure projects. Additionally, you will learn about mining equipment used to extract valuable minerals and ores from the earth. Understanding the different types and applications of these machines helps to optimize their use and ensures the successful completion of projects across various sectors. Our course highlights the importance of hauling equipment for transporting materials, debris, and machinery on construction sites. These machines are built to handle heavy loads, ensuring the efficient movement of resources and supporting the smooth operation and timely completion of construction projects. We also emphasize digitalization, which involves integrating digital technologies into construction processes. This transformation enhances project management, improves accuracy, and streamlines communication. Our course explores the various types of metal handling equipment and choosing the appropriate lifting accessories. You will also learn how to read load charts and develop detailed lift plans. Safety is a top priority, and we will address the essential safety requirement for crane operations, load testing, inspections, PPE, and crane signaling. We will also examine potential risks and preventive measures through case studies of accidents and hazards. Designed for civil and mechanical engineers, this specialization prepares students for careers in process plant, manufacturing, transportation, and construction industries. It ensures that you become proficient in adapting mechanization and managing big projects safely and efficiently. Wishing all learners an enriching and enjoyable learning experience. Thank you. Welcome to our course on construction equipment maintenance and safety. This course is designed to provide you with the essential engineering principles, methods, and practical skill necessary for regular maintenance and strict safety protocols to ensure equipment operates efficiently and safely. This course also covers the importance and the need for maintenance and its types, which helps to prevent accidents and extend the lifespan of the equipment. We'll also cover life cycle management, which involves various stages like acquiring, operating, maintaining, and disposing of the equipment. We begin by exploring the evolution of mechanization in construction, which plays a crucial role in the industry by enabling the efficient completion of projects and performing tasks that would be time-consuming or impossible manually. We have seen machines ranging from small hand tools to large heavy-duty equipment, which are essential throughout various stages of construction. To keep these machines operational, we need to perform regular maintenance as per the schedule. Effective maintenance strategies include preventive, predictive, and corrective maintenance. Comprehensive equipment management, rigorous project execution, effective utilization, and regular maintenance helps to deliver the desired outcome. In this course, you will learn how equipments are purchased, mobilized, operated, and maintained throughout its lifespan. This course also covers equipment performance parameters, which means monitoring the equipment utilization and production against its availability and capacity, respectively. Equipment performance monitoring is an important task to schedule the periodic and condition-based maintenance, which will extend the life of the equipment. This also helps to optimize and select the right capacity machines, thereby resulting in cost savings. This course aims to make you proficient in using construction equipment, which is crucial for maximizing the benefits of this powerful machinery in construction projects. It involves the ability to operate, maintain, and manage equipment efficiently and safely. Designed for civil and mechanical engineers, this specialization prepares students for careers in plant and machinery, manufacturing, transportation, and construction industries. Welcome aboard, and let's get started.
Hello learner, welcome to this module on Equipment Lifecycle Management. I am Ramachandrasekhar here. In this module, we are going to learn about Equipment Lifecycle Management, which covers topics like life cycle of the equipment, equipment operation parameters, case study on equipment performance, introduction on maintenance, types of maintenance, and maintenance practices adopted. In this topic, first we are going to understand about the life cycle of the equipment. At the end of this topic, you will learn about equipment lifecycle management and various stages of equipment lifecycle. Now let us understand what is equipment lifecycle management. Equipment with a useful life of more than 1 year and used for producing goods and services in any organization are called as fixed assets. Equipment lifecycle is a series of stages involved in the management of an asset and also called as plant and machinery. The plant and machinery used in construction companies undergoes different stages like procurement or acquisition, transporting them to the project site, commissioning them, operation and maintenance, and finally disposing of them after the completion of equipment lifespan. The process of managing all these stages in the life cycle of an equipment is known as equipment lifecycle management. Comprehensive asset management, rigorous project execution, effective utilization, and regular maintenance helps to deliver the desired outcomes. Let us now see what are all the stages of equipment lifecycle management. The first stage in equipment lifecycle management is acquisition, which means buying or owning. This includes functions like capital budgeting, technical evaluation, and owning an asset. The second stage is the operation of equipment, which includes mobilization, deployment and operating the equipment. The third stage is maintaining the equipment, which includes inventory management and schedule maintenance. The fourth stage is equipment repairs, which includes proactive maintenance, planning and execution of repairs. The fifth stage is equipment refurbishment, which includes equipment overhauling to increase the lifespan of the equipment. The sixth and final stage of equipment lifecycle management is disposal or discard, which means disposing of non-performing and obsolete equipments whose lifespan is completed. In upcoming slides, we will learn more about the individual function of it. What is an acquisition? The acquisition means buying something or owning equipment. Construction organization uses the capital budget to procure plant and machinery equipment to handle various construction activities at the project site. Let us understand what is capital budgeting. The capital budgeting is the process where companies make investments considering the ongoing projects and future prospects. Capital expenditures, commonly called capex, used to acquire new equipment. Beginning of every financial year, the capital budget is prepared category wise and approved by top management. Normally, following are the ideal categories capex budget is prepared in a construction company. They are lands and buildings, plant and machinery, office and information technology. Let us now learn about technical evaluation. Once top management approves equipment procurement through capex, quotations are collected for different models from various manufacturers along with detailed specification of required equipment suiting the project. Technical comparisons are made on all parameters of equivalent or similar models. Calling suitable vendors for discussing further technical, after sale and services. Selection of right equipment considering the current and future projects. Upon finalizing the model and vendor, procurement formalities are initiated. Now we will see various stages of procurement. Procurement is the first stage in the asset life cycle, which means the actual purchase of an asset or equipment. With the available options, the best decision will be taken to fulfill the company's requirement within the available budget. Usually, the purchase request is initiated by the project coordinator after checking the needs, and then forecasts are made to justify the actual purchase. Once the asset is purchased, it belongs to the company and depreciation is charged year on year. And in this slide, we can see various stages of procurement. So, what is an acquisition cost? As we learned earlier, the acquisition means something that is obtained or brought. On collection of offers from suitable or potential vendors, and after negotiating and finalizing the rates, the order is placed and organized for equipment delivery. Acquisition cost is defined as total cost related to procurement of equipment in order to own it. This includes all initial costs like procurement cost, freight, transportation, insurance, taxes and initial commissioning charges. Now you will learn about operations. The second stage of equipment lifecycle management is to operate. Operating equipment means ensuring all equipments owned or leased by the company is properly utilized in project sites. Mobilization, deployment and site operations are the process of operation. What is mobilization? Generally, in large construction companies, multiple projects are executed at the same time at different locations and equipment is spread across various projects. Meticulous planning is necessary for advance, that is, schedule of plant and machinery. Mobilization is placing the right equipment for the right job at right time, either by procuring or identifying from the existing fleet or hiring from the market. The suitable equipment is identified to carry out required tasks and equipment pre-inspection is to be carried out to ensure equipment is in good working condition. All necessary repair works are attended in the previous location so that equipment can be commissioned immediately without any further delay at the new location. Let us learn about hiring. Hiring is nothing but engaging equipment owned by others for executing your task. When equipment is not available and you are not able to deploy the equipment from your own fleet, then we need to engage from another party. This is called hiring and it should be always a short-term requirement. When you finalize to hire the equipment from third party, then you need to collect quotation from different vendors, negotiate the rates and finalize the vendor to deploy and commission the equipment as per the project requirement. Always ensure competent operating crew is engaged by hired vendors and all safety gadgets of equipment are working to meet the safety requirement. Now we will learn about deployment. Deployment is the act of moving something into a strategic position or position of readiness. Any delay in deploying the equipment at construction projects will lead to delay in project execution and finally profitability. Care to be given for resource planning, identification and deploying of equipment as per the requirement of project execution team. Now we will see the process of deployment. The deployment stage is a stage where all actions are to be taken place before the equipment is finally used. After receipt of all consignments, a physical inspection is carried out and equipment will be assembled and preliminary checks are conducted. Also, trail tests are performed to reconfirm equipment is performing well and all safety gadgets are working. Finally, equipment is allowed to perform an actual task in the project. The process of deployment starts with the erection of equipment, pre-commissioning and safety inspection, followed by the commissioning of equipment and finally handing over the equipment to project site for execution of project or site operations. What is site operation? Operating all available equipment requires manpower. Manpower management ensures all the equipment engaged at the project site is provided with operating crew. Site operations are to ensure equipment is available for usage. The maintenance team should continuously monitor the operation of equipment like number of hours worked, idle, breakdown, etc. Site operation team is to coordinate with execution team and ensure the right equipment is used for right job. We should always ensure operators are trained frequently. The site team has to monitor the performance parameters like availability, utility, productivity and reliability. Let us now learn about utilization. Utilization is the action of using something, that is making practical and effective use of it. Utilization is the longest stage of equipment lifecycle management. The equipment is finally put into good use for which it was purchased. The revenue and returns earned on its capital are seen with proper utilization. The performance of equipment is monitored continuously to avoid issues that may arise unexpectedly during its operation at the site. In the next slide, we will see how utilization is calculated in terms of number of equipment deployed and operation hours. As we learned earlier, utilization is a measure of actual usage of equipment. Let us see how to calculate the utilization percentage on working hours. Assume equipment is engaged and worked for 150 hours against 300 available hours. The utilization percentage is number of working hours divided by total hours, which is 150 divided by 300 and utilization comes to 50% in this case. Now we will see how to calculate utilization percentage on equipment deployment. As shown in the image, assume out of 8 available equipments, 6 equipments are engaged and working actively and the other 2 equipments is idle. The utilization percentage is number of equipments engaged divided by total number of equipments, which is 6 divided by 8 and the utilization percentage comes to 75% in this case. Now let us see about third stage of equipment lifecycle management, which is maintenance. Maintain means keeping the equipment running at high capacity and producing quality products at the lowest cost possible. It includes routine upkeep as well as corrective repair work. Equipment maintenance is required to be carried out to extend the lifespan of the equipment and to prevent unplanned downtime, which can be costly and interrupt the site or project operations. Now we will see the types of maintenance. Maintenance covers all activities which need to be attended to keep the equipment in ready and running condition to perform its intended task. Maintenance is two types. They are unplanned and preventive maintenance. Unplanned maintenance is failure based maintenance that occurs unexpectedly and they are also called as sudden breakdowns. Preventive maintenance is type of maintenance carried out to avoid sudden breakdowns. Preventive maintenance is further classified as time based, condition based and risk based. Time based, which is carried out periodically, condition based, which is carried out as a predictive maintenance, risk based, which is carried out as a proactive maintenance. We will learn more about maintenance in upcoming topics in this module. Let us now understand inventory management. Maintaining inventory is required to attend the issues in equipment and to meet the requirement of sudden breakdown and preventive maintenance. Need to prepare equipment wise maintenance schedules by considering the operating hours of the past and future. Monitoring of inventory is necessary to carry out the maintenance as per the schedule. Site team to initiate orders to source the non-available spares to attend the issues in equipment. The site maintenance team should ensure maintenance task is carried out as per the maintenance schedule and hand over the equipment back to the customer once the maintenance task is carried out. The site maintenance team also plan and forecast the inventory to meet the future maintenance requirement. What is repair? Repair is a process of restoring something which got damaged, faulty or worn out to a good condition, either by replacing a part or putting together what is torn or broken. And now let us see the actions to be taken to complete the repairs. When equipment is failed, we should immediately identify the issue in the equipment. After identifying the damaged part or accessory, the same to be dismantled from the equipment and required spares are to be organized for the replacement. Once spares are received and replaced, the maintenance team assembles the part or accessory back into the equipment. After fitment, an equipment trail test is to be carried out, and once it found safe to operate, equipment is handed over back to the execution team for usage. Now let us see the next stage of equipment lifecycle management, which is refurbishment. Generally, refurbish means to restore or to restore to the new condition or its appearance. Refurbish means restoring something to its original condition to perform better to maximize the production. In terms of equipment, refurbishment consists of identifying and replacing damaged or faulty components. It restores the equipment to its state when originally manufactured, which is why the process is often referred as remanufacturing. Once equipment refurbishment is carried out, it increases the equipment lifespan and productivity. Refurbishment reduces the downtime and increases the equipment availability to perform the task. Now we will see the stages of refurbishment. The purpose of refurbishment is to renovate and carry out repairs by replacing the spares and reclamation of structure to increase the lifespan of equipment. What are all the actions taken in refurbishment? Upon receipt of equipment for refurbishment, a trial run is carried out and identify the issues in operation. Then the equipment is dismantled completely and parts are segregated and list of spares or accessories which need to be replaced are identified. The required items for replacement are organized. Once spares are received, necessary action is taken place to replace the spares and assemble the part or accessories back into the equipment. Then commissioning and trail test of equipment happens. Finally, equipment is deployed at the required process site and equipment is handed over to the execution team to perform the intended task. Now you will understand the final and the last stage of equipment lifecycle management. The final stage of equipment lifecycle management is discard or disposal. Discard is nothing but getting rid of something as no longer useful or desirable. Discard is nothing but disposal of. The general reasons of disposal are: equipment is outdated and not up to safety norms, non-performing equipment, equipment methodology is obsolete, equipment expected life is completed, equipment having major repairs and high mean time between failures, and finally the repair cost of equipment is beyond economical. Beyond economical repairs means repair cost of equipment is too high considering the age and current value of the equipment. Technical obsolescence means parts and services supports are no longer available by manufacturer or external market. Poor reliability means equipment reliability after repairs may be poor and get frequent breakdowns. Now let us understand the benefits of equipment lifecycle management. Equipment lifecycle management helps to optimize the performance of the asset towards its useful life. The lifecycle management starts from the planning stage and moves along in a sequential manner until the equipment is no longer useful and disposed of. The proper system with database management is to be maintained, which helps to monitor the performance, operational cost and utilization associated with an asset throughout its lifetime. Ultimately, it enables you to get the most out of your money and tracks the returns on investment and also assists owner to take decisions on future investment. Now let us recall what you have learned so far. Asset lifecycle is a series of stages involved in management of an asset. The plant and machinery used in construction company undergoes different stages like procurement or acquisition, transporting them to the project site, commissioning them, operation and maintenance, and finally disposing of them after the lifetime of the equipment. The process of managing all these stages is known as equipment lifecycle management. The acquisition means to buy something or owning an equipment. Operating equipment means ensuring all equipments owned or leased is properly utilized in project sites. Maintain means keeping the equipment running at high capacity and producing quality products at lowest cost possible. Equipment maintenance is required and to be carried out to extend the lifespan of the equipment and to prevent unplanned downtime, which can be costly and interrupt the site operations. Repair is the process of restoring something damaged, faulty or worn out to a good condition, either by replacing a part or putting together what is torn or broken. Refurbishment means restoring something to its original condition to perform better to maximize the production. Renew it and carry out repairs by replacing the space and reclamation of structures to increase the lifespan of the equipment. Discard is getting rid of something as no longer useful or desirable. By this, we have come to the end of this topic. Let us meet in another interesting session. Thank you, learner.
Hello learners, welcome to this module on Equipment Lifecycle Management. Let's start with the topic on the equipment performance parameters.
At the end of this topic, you'll be able to explain about the equipment performance parameters and its importance.
Equipment performance parameters means monitoring the equipment utilization and production against its availability and capacity respectively. Equipment performance monitoring is the important task to schedule the periodic and condition-based maintenance which will extend the life of the equipment.
Performance measures of equipment. Availability, reliability, utility, and productivity are four major performance parameters that are monitored in equipment. Click and reveal performance measures of equipment to know more. Availability and reliability are the part of maintenance team. It indicates how the equipment is maintained to enhance the equipment availability to perform its intended function and also reduces the sudden downtime of the equipment. Increasing the equipment availability and reliability means equipment is available to utilize and produce more productivity and output, which in turn generates more revenue. Availability and reliability are the part of maintenance team. It indicates how the equipment is maintained to enhance the equipment availability to perform its intended function and also reduces the sudden downtime of the equipment. Increasing the equipment availability and reliability means equipment is available to utilize and produce more productivity and output, which in turn generates more revenue. Similarly, utility and productivity are part of execution team. It indicates how much time the equipment has been utilized and how much it has been produced against its capacity. These parameters are all interlinked and should be given equal importance and measured continuously to identify the gaps and work on improvements to increase profitability. Productivity of construction equipment. Productivity is measured as output produced against the capacity of the equipment. Various methods can be used to calculate productivity, and a few are listed below. Productivity is a ratio of output to input. Productivity is the ratio of output to time taken. Productivity is the ratio of actual production to target production. The productivity of construction equipment in analytical methods is defined as unit output per hour. The selection of the appropriate type and capacity of construction equipment helps to achieve the required productivity with minimum time and effort. It is important to note that equipment productivity is a measure of the overall effectiveness of organizational systems in utilizing labor, equipment, and capital to convert labor efforts into useful output. As of now, we have learned about equipment performance measures and their purpose. We will now examine how productivity is calculated against target production and number of hours worked. Assume during September 2021, a 30 cubic meter per hour batching plant has produced 1800 cubic meter against target production of 2200 cubic meter. What is the productivity of this plant? We know actual production divided by target production will derive productivity percentage, and in this case productivity percentage is equal to 1800 divided by 2200 into 100, that gives 82 percentage. Let's take a look at the next example, which is a 130 cubic meter per hour matching plant has produced 150 cubic meter in 6 hours operation. What is the productivity of this plant? We know actual produced in hour divided by capacity of production in hour will derive productivity percentage. And in this case, plant has produced 150 cubic meter in 6 hours, which means it has produced 25 cubic meter against the 30 cubic meter capacity. Here, the productivity is 25 divided by 30 into 100 gives 83 percentage. As we all know that increasing productivity increases profitability. But in general, various factors affect the productivity. We can see a few of them in this section. Drag the slider to the right to know more. Equipment availability. If equipment availability increases, productivity also increases. If availability decreases, productivity declines as well. Proper maintenance. If equipment is not maintained properly, then it will decrease the availability, which in return reduce the productivity. Utilization of equipment. Even though equipment is available, it needs to be utilized to produce the output or production. Long idling of equipment. If the equipment is idle for long time, then equipment production is reduced. Selection of right equipment. Selection of right equipment also plays major role in production. We should give utmost care in selecting the equipment to achieve the target production. If we choose low capacity equipment, then we can't reach the targets, and if we choose high capacity equipment, then we end up in producing low production against the equipment capacity, and parallelly it increases the cost of hourly production. Operator competency. Operators are the key person in operating the equipment for its intended purpose. Competency of operator is important and mishandling of equipment leads to unsafe activity, reduce the reputation of organization, loss in profits, etc. We should always ensure competent operator is engaged and operating the equipment. Operating location. Operating location also reduces the production. Always, equipment should be placed where the ground stability is good. Poor ground stability may lead to unsafe acts and also increases the unwanted vibration, etc., which reduces the production. Supporting resources. Generally, activities are interlinked and need to be produced by different equipment simultaneously and separately. To achieve good production, we should always plan the supporting resources are available and ready to use. Productivity can be increased by generating more outputs from the same level of inputs, reducing the input by maintaining the output as constant, increasing the output to a maximum extent with a smaller increase in input. For the long-term growth of the firm and the economy, a high level of productivity must be maintained. High productivity means that resources are utilized to the optimum while minimizing wastage. This leads to a reduction in the cost of production and subsequently availability of quality products to customers at lower prices. Productivity improves profit. As we have learnt earlier, productivity always enhances profitability. In this slide, we can see various factors playing a major role in increasing the rate of production. Click on each slot to reveal the common terms for grader operation. Availability. As we learnt earlier, equipment productivity increases when availability increases. Similarly, production reduces when availability decreases. Availability is based on how the equipment is operated, how the equipment is maintained, and how fast the repairs are attended. Utilization. Even though equipment is available, it needs to be utilized to produce the output. Utility is based on how the job or task is planned. How to reduce the idle time by engaging or utilizing the equipment, and how to use the equipment alternatively. Capacity utilization. Always ensure the equipment is used to its capacity. Capacity utilization is based on how the equipment is selected based on activity, the sequence of tasks, supporting resources, and maintaining a man-machine ratio. With proper maintaining, meticulous planning, continuous monitoring, and proper utilizing, we can improve the equipment productivity and enhance the profitability. What is expected from a machine? When we are investing on anything, we always expect huge returns from it. Similarly, equipment owner always expects high production with low production cost to generate huge profits. Top machine performance means lowest possible hourly costs divided by highest possible hourly production. Always remember, it is not what we produce matters, at what cost we produce matters the most. Availability is a measure of uptime of equipment, that is, how much time the equipment is available for use. Availability is calculated by total hours in a month minus breakdown hours divided by total hours in a month. Using an example, we will now calculate what is availability percentage. Assume during September 2021, a wheel loader was under breakdown for a total of 10 hours. Then, availability percentage is total hours in a month is 24 hours into 30 days, which is 720 hours. And equipment breakdown for the month is 10 hours. With the given data, we now calculate availability percentage, that is 720 minus 10 divided by 720 into 100. That gives 99%. Utility is the measure of actual usage of equipment. It is normally measured against a target of 12 hours per day. The utility is calculated by hours worked divided by total shift hours in a month minus breakdown hours. Using an example, we will now calculate what is utility percentage. Assume during September 2021, same wheel loader had run for 210 hours with a breakdown of 10 hours. What is the utility percentage? While calculating shift hours, Sundays are excluded since it is a weekly holiday. Shift hours for the month are 12 hours into 26 days, which is 312 hours. With given data, we now calculate utility percentage, that is 210 divided by 312 minus 10, the whole multiplied by 100. That gives 70%.
Reliability is the probability that equipment performs its intended function for a stated period of time under specified operating conditions. It is measured as mean time between failures, MTBF. Reliability is calculated by the hour run divided by the number of breakdown. Using an example, we will now calculate what is reliability. Considering the previous example, the wheel loader ran for 210 hours with a breakdown of 10 hours. Assuming that it was under breakdown for 7 times during that month, what is the reliability? With given data, we now calculate reliability, that is 210 divided by 7, that gives 30 hours, which means every 30 hours of operation, equipment is getting failed.
Previously, we learned what availability and reliability are and how they are calculated. Now, let us see what is a major difference between these two parameters. In the example above, we have already calculated availability and reliability. We have calculated equipment availability and it equals 99%. So out of 100%, the equipment is available for 99%, which is a good sign. We also calculated equipment reliability, which is 30 hours, which means the equipment experiences failure every 30 hours of operation, which is a bad sign. In order to know the condition of equipment, we should always calculate both availability and reliability. Availability is a measure of duration of downtime, whereas reliability is a measure of frequency of downtime. To ensure effective equipment operation, one should always know the requirement, choose the right equipment for the right job, measure performance or production of equipment, identify gaps to improve production, work on improvements. Here we see how do we increase construction equipment productivity. Plan the equipment needs. Utilize the equipment properly. Manage equipment data. Monitor operating records. Employ trained and skilled operators. Adhere to the regular maintenance schedule. Use the right equipment for the right job. Focus on value more than price. Performance of machinery can be simply improved by production monitoring systems that enable us to quickly identify, track, and rectify faults or bottlenecks in the process. They also motivate workers associated with the process to achieve targets. By automating the work, both performance and availability can be improved by using machinery. Automation helps to increase the available working hours of machinery as it is not dependent upon an operator for it to keep producing products. Example, robotic plastering. When you keep track of your construction equipment productivity, it gives us a competitive advantage in productive operation, which includes better operating performances, boosted project productivity and efficiency, extended life of the equipment, fewer repairs, improved safety, increased profits, lower operating cost, reduced fuel consumption. When you have insight into your fleet's proficiency, you can work to improve the efforts of each piece of equipment to ensure your projects are on time. Let us check how well you have understood the content covered in this topic. To begin the knowledge check, click Next.
You have learned in this topic. Operating parameters of equipment are: productivity of construction equipment is defined as ratio between the actual production divided by target production. Availability is a measure of uptime of equipment, that is, how much time the equipment is available for use. Utility is a measure of actual usage of equipment. It is normally measured against a target of 12 hours per day. Reliability is a probability that an equipment performs its intended function for a stated period of time under specified operating conditions. It is measured as MTBF, mean time between failures. We have understood the importance of operating parameters of construction equipment deployed on site.
Hello learners, welcome to this topic on case study on equipment performance. At the end of this topic, you'll be able to solve the calculations of equipment performance. Equipment performance is nothing but operating data of equipment, that is, availability, utility, productivity, and reliability. Decisions are made while investing capex, and equipment deployment was done based on equipment performance data. Equipment performance shows how effectively equipment has been utilized. Continuous monitoring of the performance of equipment helps to identify the gap and to increase its efficiency. Let us now recall the formulas of equipment performance parameters, that is, availability, utility, productivity, and reliability.
Click and reveal each parameter to recall.
Availability is a measure of uptime of equipment, that is, how much time the equipment is available for use. Availability is calculated by total hours in a month minus breakdown hours divided by total hours in a month. Utility is a measure of actual usage of equipment. It is normally measured against a target of 12 hours per day. Utility is calculated by hours worked divided by total shift hours in a month minus breakdown hours.
Productivity is measured as output produced against the capacity of equipment. We can calculate productivity by various means, and few are listed in this slide. Productivity is the ratio of output by time taken. Productivity is a ratio of actual production by target production. Reliability is a probability that an equipment performs its intended function for a stated period of time under specified operating conditions. It is measured as mean time between failures, MTBF. Reliability is calculated by hour run divided by number of breakdowns.
Equipment Performance Data, AMS, Asset Management System. In this section, we can see the performance data of different equipment for the month of September 2021. Using this data, we will now check the equipment effectiveness. Now, let us click on each case study to learn more. Company has secured new job in a new location. A boom placer is required. Now, we will see how performance data helps to identify the equipment from existing fleet. Step 1. From database management, first we will collect the operating data of all available boom placers at all locations. Step 2. Using the availability formula, we need to identify how many hours the boom placer is available to operate and produce. Availability percentage is equal to total hours in a month minus breakdown hours divided by total hours in a month into 100. Availability percentage is calculated for all boom placer. For example, availability of boom placer 2 is equal to 720 minus 221 divided by 720, the whole multiplied by 100. That gives 69%. Boom placer 4 is equal to 720 minus 0 divided by 720, the whole multiplied by 100. That gives 100%. Similarly, we will calculate availability percentage for all equipment and update it in the table. Step 3. Now we know the equipment-wise availability percentage. Next, we need to find utility percentage of all available equipment to identify low utility equipment. Utility percentage is equal to hours worked divided by shift hours minus breakdown hours, the whole multiplied by 100. Using utility formula, we will now calculate the utility of individual boom placer. For example, boom placer 3 is equal to 4 divided by 312 minus 0, the whole multiplied by 100. That gives 1%. Boom placer 4 is equal to 237 divided by 312 minus 0, the whole multiplied by 100. That gives 76%. Boom placer 8 is equal to 296 divided by 312 minus 16, the whole multiplied by 100. That gives 100%. Similarly, we will calculate utility percentage for all boom placers. In this table, we look into how decisions are made using the performance data. Conclusion. We have calculated equipment-wise availability percentage and utility percentage. By looking, we can identify one equipment, B placer 3, is underutilized even after 100% availability. And in the same job location, they have two boom placers. Now, we can dispatch low utilized boom placer immediately to new required destination. With this, we can utilize all equipment and produce output and good returns on investment. For decision making, always analyze multiple months' data to have correct feedback. We have seen how to calculate equipment availability and utility and also learnt how to identify the low utilized equipment from existing fleet using performance data. Now, we will see another case study and we are provided with daily performance data of a one-wheel loader and we need to calculate the efficiency of equipment for a given period. Step 1. First, by using above 15 days performance data, we will now calculate equipment efficiency, that is, availability, utility, and reliability for the given period. Using formulas, we will now calculate individual performance. Availability percentage is equal to total hours in a month minus breakdown hours divided by total hours in a month, the whole multiplied by 100, equal to 360 minus 35 divided by 360, the whole multiplied by 100. That gives 90%. Utility percentage is equal to hours worked divided by shift hours minus breakdown hours, the whole multiplied by 100, equal to 102 divided by 180 minus 35, the whole multiplied by 100. That gives 70.34%. Reliability is equal to mean time between failures, equal to hours run divided by number of breakdowns, equal to 102 divided by 7, that gives 15 hours. Seems this wheel loader is getting breakdown for every 15 hours of operation. We have seen how to calculate equipment availability and utility and also learnt how to identify the low utilized equipment from existing fleet using performance data. Now, we will see another case study and we are provided with daily performance data of a one-wheel loader and we need to calculate the efficiency of equipment for a given period. Step 1. First, by using above 15 days performance data, we will now calculate equipment efficiency, that is, availability, utility, and reliability for the given period. Using formulas, we will now calculate individual performance. Availability percentage is equal to total hours in a month minus breakdown hours divided by total hours in a month, the whole multiplied by 100, equal to 360 minus 35 divided by 360, the whole multiplied by 100. That gives 90%. Utility percentage is equal to hours worked divided by shift hours minus breakdown hours, the whole multiplied by 100, equal to 102 divided by 180 minus 35, the whole multiplied by 100. That gives 70.34%. Reliability is equal to mean time between failures, equal to hours run divided by number of breakdowns, equal to 102 divided by 7, that gives 15 hours. Seems this wheel loader is getting breakdown for every 15 hours of operation. In case study 2, we have learnt how to calculate equipment availability, utility, and reliability using performance data. Now in case study 3, we will see how to calculate production of equipment. Step 1. By using above production data, we will now check the productivity of each batching plant. As we have learnt earlier, productivity is equal to actual production divided by target production. Benchmark target production for 30 cubic meter per hour batching plant is 2700 cubic meter per month, whereas 56 cubic meter per hour is 5600 cubic meter. Let us now calculate productivity of batching plant 1 and its target production for the month is 2700 cubic meter. Productivity for the month of August 2021 is 1751 divided by 2700, which comes to 65%, But while calculating production for given 3 months period, then we need to average actual production, that is 2238, and productivity of 3 months, that is 2238 divided by 2700, that gives 83%. Similarly, we will calculate productivity percentage for all 30 cubic meter batching plants. As we know, the benchmark target production of 56 cubic meter per hour is 5600 cubic meter per month. From available data, let us now calculate the productivity of batching plant 2, and its target production for the month is 5600 cubic meter. Productivity FTM September 2021 is equal to 1338 divided by 5600, that gives 24%. And when we calculate production for given 3 months period, then we need the average actual production, which comes to 1558 cubic meter, and productivity of 3 months is equal to 1558 divided by 5600, that gives 28%. Similarly, we will calculate productivity percentage for all 56 cubic meter batching plants. Only by monitoring the equipment performance, one can identify the gaps and work on improvement to obtain the maximum possible output from equipment. It is possible to achieve the best returns on capital investment by constantly monitoring equipment performance, resolving issues with equipment, and providing scope to maximize its performance. Based on performance, management can decide either to deploy the equipment to increase production or demobilize or remove the equipment to increase utility and productivity. Based on equipment performance data, maintenance schedules are prepared to keep the equipment in proper working condition, reduce downtime, and carry out maintenance in a cost-effective way. Hence, utmost importance is given to collecting the operation data of individual equipment to monitor the performance of equipment, to identify the gap and work on improvement, and also to carry out equipment maintenance as per the schedule to increase the lifespan of the equipment. Let us check how well you have understood the content covered in this topic. To begin the knowledge check, click Next.
Have learned in this topic. We have seen case studies and performance data that assist us in making decisions.
Hello learner, welcome to this topic on introduction of maintenance. This is Ramachandra Shekhar here. In the previous topic, you have learned about how to calculate and monitor the performance of equipment. At the end of this topic, you will learn about maintenance and its purpose. First, let us know what is maintenance. The dictionary defines maintenance as follows: the work of keeping something in proper condition, that is upkeep. Maintenance is Hello learner, welcome to this topic on introduction of maintenance. This is Ramachandra Shekhar here. In the previous topic, you have learned about how to calculate and monitor the performance of equipment. At the end of this topic, you will learn about maintenance and its purpose. First, let us know what is maintenance. The dictionary defines maintenance as follows: the work of keeping something in proper condition, that is upkeep. Maintenance is the activity to keep the equipment in good working condition. This would indicate that maintenance should be the actions taken to prevent a device or a component from failing or avoiding repairs of equipment. Maintenance is not only to repair the broken equipment rapidly, it is to keep the equipment running at high capacity and produce quality products at lowest cost possible. It is the process of preserving the condition of equipment to carrying out its intended function. The maintenance procedures helps to identify the faults in the equipment and rectifies the same before it gets failed. We can utilize the equipment more effectively by carrying out the equipment maintenance as per the schedule. Now let us see how maintenance is carried out in olden days and how maintenance is carried out now. Many years ago, the construction activities were done by using simple technical equipment and by involving more manpower. Maintenance was of course simple and impact is only to a certain extent in equipment function. Due to continuous improvement and evolution of high mechanized equipment and in connection with high technical development, the impact of productivity and quality has moved from man to machine. In earlier days, they used simple equipment and operates till it gets failed and broken. They used to attend repairs only when the equipment is no longer running. Downtime maintenance was not as serious and critical as it is today, since major operations are depending on manpower. Their focus was only on a corrective action and there is no focus on planned or preventive maintenance, whereas today operations are mostly depending on equipment and downtime of equipment leads to low productivity and huge losses. Hence, we need to focus more on preventive and proactive maintenance. The importance of maintenance has considerably increased now. Let us now see the importance of maintenance. Maintenance is required to keep the equipment in good working condition. Plant and machinery equipment is the heart of construction projects. Maintenance is an important task to be carried out to minimize failures. Maintenance needs to be carried out regularly to keep the equipment in condition to produce high productivity, which gives high profits. Maintenance has significant importance in extending the equipment life, and carrying out maintenance regularly saves time and money and increases productivity. Let us now see more about importance of maintenance. To maximize equipment productivity and performance, proper maintenance needs to be carried out, which helps to prevent the breakdown of sudden failures of equipment. Moreover, the nature and project conditions like extreme humidity and dusty require special upkeep of equipment. By carrying out maintenance regularly, we can increase the safety of both equipment and operating crew by reducing the risk of injuries and fatalities due to equipment breakdown or malfunctions. We can reduce the equipment operating cost by carrying out regular maintenance, whereas the repair cost of sudden breakdowns is costly and time consuming. We can operate equipment continuously to meet the schedule and commitments by proper maintenance. Let us know when maintenance need to be considered. Maintenance must be taken into consideration in the very early stage, that is procurement of new equipment. Based on the original equipment manufacturer maintenance manual, schedules need to be prepared. Required spares, consumables and maintenance crew need to be organized to carry out maintenance as per the schedule. Doing maintenance from the beginning will keep the equipment's condition to the mark. High quality equipment will give high reliability and maintainability, which secure high productivity and equipment efficiency. The highest hourly production with lowest production cost is always expected from the equipment, and this is achieved only by proper maintaining of equipment. Let us now recall different types of maintenance. As we learned earlier, maintenance is preserving something to continue in the existing state and an activity to ensure maximum uptime of equipment. Maintenance is two types. They are unplanned and preventive maintenance. Unplanned maintenance is failure-based maintenance that occurs unexpectedly and is called as reactive maintenance. They are also called as sudden breakdowns. Preventive maintenance is a type of maintenance carried out to avoid sudden breakdowns. Preventive maintenance is further classified as time-based, risk-based and condition-based. Time-based is known as periodic maintenance, risk-based is known as proactive maintenance, condition-based is known as predictive maintenance. In upcoming slides, we will learn more about individual types. Let us now learn about individual type of maintenance. Reactive maintenance is known as breakdown maintenance. This type of maintenance is carried out only when the equipment is failed, which means the issue is fixed when the equipment is down. As we learned earlier, preventive maintenance is time-based, risk-based and condition-based. Periodic maintenance is also called as time-based maintenance. This type of maintenance is carried out based on the schedules which are at regular interval, and proactive maintenance is also called as risk-based maintenance. This type of maintenance is carried out based on the risk and it eliminates defects at early stage. Predictive maintenance is also called as condition-based maintenance. This type of maintenance is carried out based on the condition and it uses analytics to predict the equipment failures and attend before it gets failed. Let us now see difference between preventive and reactive maintenance. Preventive maintenance is carried out before the failure occurs and it prevents failure, whereas reactive maintenance is carried out after the failure occurs. Preventive maintenance requires less time to complete the task and does not impact the project schedule, whereas reactive maintenance is the time consuming process and requires more time to complete the task and impacts the project schedule. Now let us see more difference between preventive maintenance and reactive maintenance. Preventive maintenance prevents downtime of the equipment, whereas reactive maintenance is an unplanned and sudden breakdown that leads to downtime. Proper planning and scheduling to be done to carry out preventive maintenance. Reactive maintenance is a sudden breakdown, so they do not need any planning in advance. Once breakdown occurs, planning and coordination are required to source the required spares and to put the equipment back into operation. By carrying out preventive maintenance regularly, we can extend the life of equipment, whereas in reactive maintenance is done only after the breakdown of the equipment. Due to frequent breakdowns, life of the equipment is reduced. We can increase productivity and profits by carrying out preventive maintenance regularly as per the schedule. Whereas in reactive maintenance, due to sudden breakdown of equipment, required resources to be carried out maintenance tasks will not be available and it takes more time to complete, and this process impacts the production. In preventive maintenance, due to proper planning, we can source the material in advance and have enough time to negotiate and reduce the cost of materials. Reactive maintenance need to be attended on war-foot basis and the cost of material is high. Preventive maintenance needs less time to complete since planned maintenance needs to be attended, whereas reactive maintenance needs more time to complete since the list of repairs is not known. Preventive maintenance reduces the risk of injury, whereas reactive maintenance poses safety risks. Let us now understand about equipment maintenance. Equipment maintenance is the process used to keep the equipment in reliable working condition. It includes routine upkeep of equipment as well as corrective repair works. Construction equipment maintenance looks at repair work as preventive and breakdown. They also call it as scheduled and unscheduled repairs. Preventive maintenance is far more cost effective than reactive, which is post breakdown repairs. Routine and preventive maintenance saves huge cost to construction companies compared to breakdown maintenance. Breakdown maintenance requires expensive parts replacement and downtime is more due to unexpected failure which happens suddenly and the non-availability of components. Let us now see the importance of maintenance. All companies and organizations are interested in lowering the maintenance cost. A very common misunderstanding is that the product gives the income, whereas maintenance costs money. Maintenance which is not carried out regularly will cost even more than money. If maintenance is not done as per the schedule, equipment will fail and will not be able to produce. If maintenance is not done, equipment will fail and the cost of repairs to put back the equipment into operation is more. Similarly, there are many drawbacks if maintenance is not done. With proper maintenance, we can always save money and increase profit. Now let us recall what you have learned so far. Maintenance is the activity to keep the equipment in good working condition. Maintenance is carried out to prevent a device or component from failing. Maintenance is not to repair the broken equipment rapidly. It is to keep the equipment running at high capacity and produce quality products at lowest cost possible. Maintenance needs to be carried out regularly to keep the equipment in condition to produce high productivity, which will generate high profits. Carrying out maintenance regularly extends the life of the equipment and ultimately saves time and money. There are two types of maintenance. Reactive maintenance is carried out after the failure occurs in the equipment. Preventive maintenance is carried out before the failure occurs in equipment. By this, we have come to the end of this topic. Let us meet in another interesting session. Thank you, learner. Hello learner, welcome to this topic on introduction of maintenance. This is Ramachandra Shekhar here. In the previous topic, you have learned about maintenance, and in this topic, you will learn more about maintenance. At the end of this topic, you will learn about equipment maintenance management and various stages of equipment maintenance. Now we will learn about equipment maintenance management. Various stages are involved in equipment maintenance management. The first and early stage in equipment maintenance management is monitoring and recording the performance of equipment for preparing the maintenance schedule plan. In the second stage, once equipment performance data is collected, we need to identify the list of equipments that falls under scheduled maintenance. Then in third stage, planning and scheduling are prepared for all available equipments, and the type of schedule is also identified, like 50 hours, 100 hours, 250 hours, 500 hours, etc. as per the manufacturer's recommendation. In the fourth stage, based on the maintenance schedule, required resources and materials are organized either from the existing inventory or by procuring. In the fifth stage, coordinating with the project execution team and arranging equipment for maintenance as per the schedule. In the sixth stage, once the equipment is released from the project execution, maintenance task is carried out and all required resources and consumables are replaced as per the schedule. In the seventh stage, all records are updated regarding the maintenance and activities involved while attending the maintenance task, along with the list of spares and consumables replaced. And the last and final stage in equipment maintenance management, in this stage, equipment is tested in all aspects, and once it is found fit, the same will be engaged and perform project activities. In upcoming slides, we will see more about individual functions. Now we will learn about monitoring and identifying in maintenance. Maintenance is carried out on available equipment at the respective project site by the concerned maintenance crew. The maintenance crew collects the equipment performance data on daily basis and analyzes the operating data of previous months, and also estimates approximate working hours for the month and identifies the list of equipments falls due for the maintenance, like 50, 100, 250 and 500 hours, etc. The maintenance crew carry out daily inspection of equipment and records all the findings and update the database. Based on experience and expertise, they identify the issues and damaged components which are likely to fail in the equipment are replaced before it gets failed by carrying out maintenance tasks in a cost-effective way. Let us now learn about planning and scheduling of maintenance. To plan and prepare a maintenance schedule, one should monitor the equipment performance regularly to estimate approximate working hours for the month. The maintenance team prepares the maintenance schedule by considering the previous month's utilization, current month utilization and future utilization. The maintenance team shares the maintenance schedule with the operations and execution team and fixes an approximate date to carry out maintenance activity. The maintenance team prepares a maintenance checklist as per the original equipment manufacturer standards and site conditions. The maintenance team plans and organizes required resources like spares, lubricants and in-house maintenance crew to carry out maintenance, and also organize original equipment manufacturer services if required. They also arrange necessary tools and tackles to attend the maintenance task as per the schedule. Let us now understand the functions of execution in maintenance. Before executing the maintenance task, the maintenance in charge conducts a toolbox meetings with the maintenance crew detailing the list of activities to be performed and its sequences. The maintenance crew carry out maintenance as per the checklist under competent supervision. The maintenance crew carefully inspects all components of the equipment and replaces damaged, faulty and worn out components. They also clean the equipment including internal subassemblies. They lubricate the equipment and also check for the proper functioning of grease nipples. They replace all required consumables like oil, filters, etc. as per the maintenance checklist. Maintenance in charge ensures all activities are carried out as per the maintenance checklist. Now let us see the purpose of maintaining the records of maintenance. After carrying out maintenance, the following details need to be recorded for analyzing the data and scheduling the next maintenance. Actual hour meter reading or kilometer reading and type of maintenance carried out need to be updated in the records. Any major deviation in hour meter reading or kilometer reading when compared to the schedule and actual maintenance need to be updated. List of spares that are replaced also need to be updated for monitoring the cost of maintenance. Any abnormal damages, wear and tear and premature failures of spares and components need to be updated in the records. Based on these inputs, the next maintenance schedule is prepared by the maintenance in charge considering all major spares and consumables which need replacement during the next schedule. Now let us see the importance of review and analyzing the maintenance task. Maintenance in charge analyze the reason for major deviation in carrying out maintenance task to avoid reoccurrence. Equipment wise productivity is monitored and in case of low productivity, equipment is fully inspected to identify the issues in the equipment and works on improvement. The maintenance in charge analyze the list of spares and lubricants replaced and also organize the inventory for future maintenance tasks. In case of any abnormal consumption of spares and lubricants are noticed, then maintenance in charge takes the necessary action to rectify the same. Maintenance in charge also monitors equipment wise operation and maintenance cost. The maintenance in charge also checks the breakdown or repair history and analyzes the mean time between failures, which is MTBF. MTBF is the average time taken between two equipment failures. Based on the maintenance records and repair history, the maintenance in charge analyzes the reason behind the failure and rectifies the same to avoid recurrence. Maintenance in charge organizes the additional resources like maintenance crew, spares, lubricants, tools and tackles, etc. which are needed to carry out maintenance activities. Maintenance in charge also standardizes the maintenance schedule by reviewing and considering the previous maintenance tasks and original equipment manufacturer recommendations. Maintenance in charge conducts training to the maintenance crew regularly on the process and how to complete the task in the fast and safest way. Let us learn about inventory management. Inventory management is another important task that needs to be taken care of to perform the maintenance task as per the schedule. Inventory management is a process of planning, scheduling, ordering, storing and utilizing the spares and components which need to be replaced during the task and future tasks. For all regular consuming spares, necessary action to be taken to place an order for replacing the consumed component and keep the spares in stock for next schedule. Maintenance in charge does advanced planning and maintains necessary stock to carry out maintenance tasks without any delay. Let us now see the benefits of maintenance. By carrying out maintenance regularly, we can reduce breakdowns or downtime of equipment, increase rate of production, improve equipment efficiency, minimizing energy usage, improve inventory control, optimize useful life of the equipment, minimize repair time and cost, controls budget, optimizing resource utilization and improves safety standards. Let us now recall what you have learned so far. Understood various stages of equipment maintenance management, which are monitoring the performance, identifying the issues, planning and scheduling the maintenance task, organizing the resources, executing the task and finally updating the records. The maintenance crew collects the equipment performance data and analyzes operating data of the previous month and estimates approximate working hours for the month and identify the list of equipments fall due for the maintenance in the month. The maintenance team prepares the maintenance schedule, shares the maintenance schedule with the operation team and fixes the approximate maintenance date. The maintenance team prepares an equipment-wise maintenance checklist as per the original equipment manufacturer standards and recommendations. By considering the site conditions, maintenance in charge organizes the required resources like spares, lubricants, in-house maintenance crew, etc. to carry out maintenance as per the schedule. The maintenance team records the work carried out, parts replaced, duration of the maintenance, hour meter reading or kilometer reading of the equipment, etc. for reviewing and analyzing the data, which helps to anticipate the failures and helps in organizing the components. By carrying out maintenance as per the schedule, we can optimize the utilization of resources and improve the safety standards. By this, we have come to the end of this topic. Let us meet in another interesting session. Thank you, learner. Hello learner, welcome to this topic on types of maintenance. This is Ramachandra Shekhar here. In the previous topic, you have learned about maintenance. At the end of this topic, you will learn more about types of maintenance and its uses. Let us recall what is maintenance and different types of maintenance. As we learned earlier, maintenance is preserving something to continue in the existing state, an activity to ensure maximum uptime of the equipment. Maintenance is two types. They are unplanned and preventive maintenance. Unplanned maintenance are failure based, which means reactive maintenance. They occur suddenly and also called sudden breakdowns. Preventive maintenance is a type of maintenance carried out to avoid sudden breakdowns. Preventive maintenance is further classified as time based, risk based and condition based. Time based is known as periodic maintenance, risk based is known as proactive maintenance and condition based is known as predictive maintenance. In upcoming slides, we will learn more about individual type. Let us now learn about reactive maintenance. Reactive maintenance is also known as breakdown maintenance. Maintenance and repairs are carried out when equipment has already broken down. In reactive maintenance, once equipment is failed, necessary action like identification of problem, sourcing of spares and repairs to be taken place to restore the equipment to its normal operating condition. Reactive maintenance are unplanned breakdown maintenance and they happen suddenly. This type of maintenance takes a lot of time to put back the equipment into operation due to unavailability of spares and other resources. Reactive maintenance need to be attended on war-footy basis as it impacts the project schedule. Let us now see the causes of breakdown maintenance, that is repairs. Sudden failures and it takes time to identify the issue. Job gets disrupted due to unavailability of equipment and also affects job planning. Chain of related equipment and other resources get affected and they are unutilized. Need to organize alternate equipment which will also increase the cost of project. Time consuming repairs due to non-availability of spares. Costs very high since there was no scope to negotiate. May require shifting of equipment to repair yard, which will be additional cost. Now we will learn about preventive maintenance. Preventive maintenance is planned maintenance that extends the lifespan of the equipment. Preventive maintenance includes adjustment, cleaning, lubrication, repairs and replacements. By carrying out preventive maintenance regularly as per the schedule, we can reduce the sudden failures or breakdown of the equipment. Preventive maintenance is carried out to improve the performance and safety of the equipment. Now we will see more about preventive maintenance. During preventive maintenance, worn-out components are replaced before they fail. Cleaning and restoring the components before the performance degrades. Preventive maintenance avoids the consequences of components or system failures. Preventive maintenance improves reliability and predictability. During maintenance, the maintenance crew gets trained on proper procedures, techniques and safe work methods. Now we will see how preventive maintenance is conducted. Preventive maintenance also involves visual inspection, technical monitoring and oil analysis to anticipate problems and fix them before they become serious. Preventive maintenance takes a team approach to identify the issues and look after the equipment properly. It involves the original equipment manufacturer's recommendation as well as applying what a specific company experience tells it about a particular component of the equipment, like how many hours it can operate, what is the available wear in the component, etc. to identify the issues well in advance. Effective preventive maintenance also includes inputs from operators and frontline mechanics to identify the issue before it fails, because no one knows the equipment better than the people who build it, run it and repair it. Let us now see the benefits of preventive maintenance. Preventive maintenance saves money by preventing costly repairs. It also reduces the operating cost. It also avoids procurement of spares in emergency. It increases productivity and profits. Preventive maintenance is more maintenance, fewer repairs. It includes scheduling and carrying out maintenance regularly, increases equipment lifespan, reduces need for costly components, reduces downtime of equipment. Preventive maintenance also provides safety and comfortability, addresses issues before it becomes urgent, prevent activities on warfoot basis, gives time to complete the task smoothly, improves safety of the equipment, operation and maintenance activity. Let us now learn more about different types of preventive maintenance. Preventive maintenance tasks should be completed to prevent equipment breakdown. These precautionary tasks should be performed on all parts and components with age-related failure patterns. Adhere with the equipment maintenance manual and manufacturer recommendations. Determine the type of preventive maintenance which is required for your equipment. Thus, preventive maintenance falls into three primary categories as periodical maintenance, which is time-based, predictive maintenance, which is condition-based, and proactive maintenance, which is risk-based. Now we will see what periodical maintenance is. Periodic maintenance is preventive maintenance and it is also called as time-based maintenance. Maintenance activity needs to be performed as per the maintenance schedule set by the original equipment manufacturer. Maintenance schedules are prepared and performed at set time intervals while the equipment is operational, which are 50 hours, 100 hours, 250 hours, etc. By carrying out maintenance as per the schedule, we can prevent problems before they occur. Let us now see more about periodical maintenance. Maintenance is carried out in time intervals like 50 hours, 250 hours, 500 hours, etc. Equipment-wise maintenance checklist is defined by original equipment manufacturer, customized to suit the project conditions. Mostly consumables like filters, V-belts, lubricants, coolants, etc. are replaced. Costs less per maintenance, needs less time and they are recurring nature, and maintenance must be done. Now we will see what predictive maintenance is. Predictive maintenance is called condition-based maintenance. Predictive maintenance is an advanced form of preventive maintenance aimed at reducing the number of necessary planned tasks. Predictive maintenance is carried out by continuous monitoring and analyzing the condition of the equipment. By sensing and visual inspection of the equipment, the maintenance crew identifies the faulty or degraded component and arrange procurement for immediate replace, thereby avoiding failures that are likely to be happen. Let us now see more about predictive maintenance. Maintenance task is carried out upon getting some symptoms. During maintenance, either they replace or repair the assemblies or sub-assemblies. Maintenance cost is medium. This type of maintenance can be planned and work is disrupted minimum, carries good quality repairs to ensure non-recurrence. Now we will see what proactive maintenance is. Proactive maintenance is carried out before any significant breakdowns or failures occurs in the equipment, which means it eliminates defects at an early stage. Proactive maintenance is a type of maintenance that tries to identify and fix the root causes of the equipment failures and avoid downtime or repairs. By collecting equipment performance data, repairs history, past experiences, inspections and tests helps to identify the optimal requirement. For example, lubricating machines reduce wear and tear and avoid corrosion. Let us now see more about proactive maintenance. Maintenance aims at avoiding the root causes of equipment failures. Studies past repair history to identify the root cause of failure. Major component repairs are avoided, which saves time and money. Identify and carry out tasks in a systematic way to avoid failure. Reduce the downtime and extends the lifespan of the equipment. You minimize the cost of repairs. Let us now see the maintenance proportions. In this slide, we can see how frequently the periodical maintenance is happening and the cost incurred to carry out the maintenance and the rate of production loss during the maintenance. From the chart, we can clearly understand even the frequency of repairs is high in periodical maintenance, the cost and production losses are low. Let us now compare periodical maintenance and preventive maintenance. In this slide, from the chart, we can clearly understand even the frequency of repairs is low in preventive maintenance, the cost and production losses are high when compared to periodical maintenance. In this slide, we can see the comparison between periodical maintenance, preventive maintenance and breakdown maintenance. From the chart, we can clearly understand even the frequency of repairs is too low in the breakdown maintenance, the cost of repairs and production losses is too high when compared to periodical and preventive maintenance. Now we will recall what you have learned so far. Maintenance is to keep the equipment running at high capacity and produce quality products at the lowest cost possible. It is an activity to ensure maximum uptime of equipment. There are two types of maintenance. They are planned maintenance, that is preventive maintenance. Next, unplanned maintenance, which is sudden or breakdown maintenance. Preventive maintenance is further classified as periodic, predictive and proactive maintenance. Reactive maintenance are unplanned and sudden breakdowns. Maintenance is carried out when equipment has already broken down, and maintenance is carried out to restore the equipment to its normal operating condition. Preventive maintenance is planned maintenance that extends the lifespan of the equipment. By carrying preventive maintenance regularly as per the schedule, we can reduce the sudden failure or breakdown of the equipment. Periodic maintenance is time-based. Maintenance is carried out based on schedule and time intervals. Predictive maintenance is condition-based. By sensing and visual inspection, maintenance is carried out based on the condition of component or equipment. Proactive maintenance is risk-based. It identifies and fixes the root causes of equipment failures. By this, we have come to the end of this topic. Let us meet in another interesting session. Thank you, learner. Hello learner, welcome to this topic on maintenance practices adopted. This is Ramchandra Shekhar here. In the previous topic, you have learned about types of maintenance. At the end of this topic, you will learn more about various maintenance practices being followed. Let us see various maintenance practices and systems. MOS, which is the maintenance operating system. MMMs, which is maintenance management system. MRS, which is maintenance reliability system. MPS, which is maintenance planning system, and MES, which is maintenance efficiency system. In upcoming slides, we will understand more about individual systems. Let us now learn about maintenance operating system. The maintenance operating system sets and defines who, when and how the maintenance task is to be carried out. The salient features are sets up the workflow, scheduling the work, prioritizing the work, processing the work, closing out the work and reporting the completion of work. Now we will see what maintenance management system is. The maintenance management system executes and controls the maintenance task and its cost. Implementation of ISO, which is the International Organization for Standards, will help in more accountability and better fleet management. ISO covers all standard operating procedures pertaining to maintenance management. Silent features of maintenance management system is planning, controlling and organizing the maintenance, setting up ISO standards, ensures availability of equipment, manage and measure the performance, sets up the system to capture maintenance records and cost details. Now we will learn about maintenance reliability system. Maintenance reliability system ensures regular inspection of equipment to identify the issue in equipment and to upkeep the equipment condition. Silent features of maintenance reliability system is to set up the preventive maintenance and pre-dispatch maintenance plans which are needed to lower the cost and improve the equipment reliability. Maintenance checks in equipment need to be inspected daily before proceeding with operation. Ensures daily checklists are maintained to upkeep the equipment condition. In this slide, you can see sample format of the daily checklist, maintenance schedule and pre-dispatch maintenance. Checklist for maintenance schedule is prepared and based on the maintenance schedule, the record is maintained whether all required areas are covered and what type of maintenance is carried out like cleaning, replacing and adjustment, etc. What is pre-dispatch maintenance? Pre-dispatch maintenance is carried out when equipment moves from one location to another location. Complete equipment inspection is carried out and necessary corrective actions are taken place before dispatching, and all the inputs and actions taken are captured in PDM report. Let us now see the importance of maintenance checklist. The maintenance checklist is a basic document where a list of activities that need to be performed during maintenance. Equipment-wide checklists are prepared comprehensively. Every crucial and non-crucial maintenance points is also covered. In the checklist, it is clearly mentioned which component need to be checked and which need to be replaced and what intervals. They also remind the maintenance crew to anticipate problems which are slowly developing in the equipment so that they can check and take corrective measures before something fails. Checklists have item-wise points that remind a crew to pay attention to all points in details. Checklists are crucial and basic document for every construction equipment to carry out regular and preventive maintenance correctly. Now we will see few common and important maintenance checklist points of construction equipment. Batteries often lose charge or die on short notice. Checklist should include the battery's age, voltage retention and acid ratio. It is also important to check the condition of terminals and battery cables. Belts. Most construction equipment has belt-driven components like compressors, alternators and pumps. Belt age, wearing and discoloration should also be checked and noted in checklist. Body. The general body condition should be inspected and recorded in a checklist. The damages like rust, looseness, cracks in joints and paint conditions also to be noted. Brakes. The brake condition should be on the top of the checklist point. Brakes are the most important in any equipment. Condition of brake pad, brake shoe, brake drum, disc health, fluid levels, pressure and cable conditions are to be observed critically. Coolant. Cooling the equipment components is necessary to maintain the required temperature in the equipment. Coolants are used to cool the components and they need to be maintained in level. Radiator and transmission coolants tells a lot about equipment state. Aside from the adequate levels and normal colors, coolant should have periodic analysis to check for internal problems that cannot be detected by the eye. Electrical. Electrical component checklists go beyond battery conditions. Checklists include voltage and ampere testing and cable examination and fuse conditions to have healthy equipment electrical components. Exhaust. Exhaust system tells a lot about engine performance. One can identify the condition of engine by an abnormal sound and also by exhaust smoke. Color of exhaust smoke need to be observed and recorded. Filters. Filters are the important element that supplies purified air, filtered oil by respective filters. Every filter on the equipment must have its own check off that includes oil, fuel, air and hydraulic filters. Checklist remarks should include whether filters were cleaned or replaced during the inspection. Fluids. Checking equipment fluid is mandatory in every scheduled service inspection. Fluid analysis like engine oil, hydraulic oil, transmission fluid and engine coolant is like a blood test for humans. They reveal what is going inside the equipment. So, color of individual fuel need to be recorded. Fuel. Gasoline, diesel and propane fuel functions are extremely important to the equipment operation. Without proper functioning of fuel delivery system, the equipment cannot be operated. The checklist must ensure there are checkmark spots for fuel pumps, lines and storage tanks. Injectors. Diesel engine rely on injectors for fuel delivery. Injector cleaning or replacement must be the part of maintenance checklist. Lubrication. Lubrication helps equipment components to reduce friction. Greasing and lubrication should be on the checklist. The list should also identify critical moving areas like joints and sleeves. Safety. Safety is the most important task in operating the equipment. Each equipment is provided with necessary safety devices like safe load indicators, sensors, load cells, etc. Function of all safety devices need to be recorded in the checklist. Steering. Every part of equipment steering system needs preventive maintenance. Condition of tie rods, ball joints, idler arms and even the wheel condition to be inspected and recorded. Based on specific equipment, other critical components need to be identified and to be monitored on daily basis and same need to be recorded in a daily checklist. Now we will learn about maintenance planning system. Maintenance planning is an important task to identify the list of equipment that falls under maintenance. Based on operation parameters, maintenance planning and scheduling is done. All supporting resources and required materials are listed and need to be arranged. In this slide, you can see sample format of maintenance schedule. Now we will learn about maintenance efficiency system. In a maintenance efficiency system, all information and cost incurred for carrying out maintenance are recorded for future transactions and analytics. It measures equipment-wise maintenance cost, labor usage, labor effectiveness, and system effectiveness for maintenance performance and methods for tracking, reporting, and works on improvement. Let us see the best practices to reduce the equipment maintenance cost. Scheduled maintenance is a preventive maintenance program predicts equipment problem before they failure in cost effective way. Operator training is important since equipment life depends on the operator hand, the way they operate and they maintain the equipment, which directly reflects in improving or degrading the lifespan of the equipment. Invest on experienced staff. Skilled professionals has depth knowledge about the equipment and its features, which improves overall condition of equipment. Genuine spares are always preferred instead of adjusting with alternatives, which may lead to major failures. Now let us recall what you have learned so far. You have seen various maintenance practices being followed to keep the equipment in good condition, like the maintenance operating system sets and defines who, when and how the maintenance task is to be carried out. The maintenance management system executes and controls the maintenance task and its cost. Maintenance reliability system ensures the regular inspection of equipment to identify the issues in the equipment and to upkeep the equipment condition. The maintenance planning system identifies a list of equipment which falls under maintenance. The maintenance efficiency system records and maintains all information and cost incurred during maintenance for future transaction and analytics. And we also seen the detailed daily maintenance checklist points and their importance. By this, we have come to the end of this topic. Let us meet in another interesting topic. Thank you, learner.